Thanks very much for coming. I think you're some of the few who've actually braved the really horrible weather outside, and we've also got our online audience. So thanks very much for coming to this Oxford Energy talk. My name's Tina Forsyth. I'm the convener of the Energy series. This is Karen, who's the coordinator. Just get the titles wrong. Before introducing our speaker this before, I just wanted to briefly mention next week's talk, so you know what's coming up. So it will be the same time, same place. It's got a title that honestly I don't understand, but some of you might get it. It's called "I Yarn Teller You What LMFC Cells Are Going to Be Big." This is something about batteries. It's some sort of battery-based pun. But it's by a guy called Professor Lewis Piper from Warwick University, and so I think it was obviously be a good talk. So this week's speaker is Paul Cross, who's head of carbon and energy in our Oxford University's Estates Department. Paul probably will explain a bit about his role and what he does, but he's worked in estates and facilities management across a wide range of sectors, and has been at the university a couple of years.
Just 1 year.
Just 1 year. Yeah. Wow. Okay, just 1 year. And I noticed under the sort of blurb he gave us for the talk, he said he was sort of in charge of the heat decarbonisation plan for the university, and it's proving to be even more complicated than at first thought. But he's a natural optimist, so he believes we're going to get there. So, all right, Paul.
Great, thanks, Tina. So, hi, and hello to everyone diving in. So I'll just make sure I can get this to work. I think I can just move that. So thank you very much for inviting me first. It's a pleasure to be here, especially as I'm not a doctor or a professor. I've been here for a few, and generally people that are here are quite eminent, academics. So I'm just a lowly general practice surveyor. And so my job is to coordinate the efforts of helping the university to get to net zero, particularly in this case, in terms of heat decarbonisation. So I'm going to just bang in the sort of the really early stuff. I don't really know where to pitch this, because there are people in the room and people watching this who are going to know so much more about this subject than I will. But on the other hand, I've got a broader knowledge, I suppose, of all the different areas in terms of how we're applying this art. So this is really an applied thing, but also what I've done, I've tried to raise the questions that are really concerning us about this, and the questions we're going to try to answer. And we are working with an academic group which is led by Paul Shearing, and there's lots of colleagues there who are going to help us to answer these questions. So for anyone who doesn't know, this is our environmental sustainability strategy, net zero by 2035. Been around since 2021. It's going to be reviewed in terms of the how it's actually delivered this year. But that doesn't mean they're going to review any of the targets. They're going to keep those in place. And click that again. There we go. So this is the it's a bit old. I haven't got the new ones yet, sorry, but these are our emissions, and most of it's scope 3, as you'd expect, but some of it's scope 1 and 2. And what we're focusing on is those ones that we've got some kind of control over. So I've greyed out all of those which we've got much less control over, and the two that we've got more control over is scope 1 and 2. Scope 1, they're the tricky emissions, of course, because there's no plan. If we were back in the 1930s, then every building, all the 200 odd buildings, would have smokestacks all rising out of them. We don't do that because we're burning gas, but we're still burning gas and emitting, carbon out of most of them. And so we're going to focus on the scope 1 emissions, and that's what I've sort of got to do. Scope 2 has got a plan, and we're not going to go into that. Other people will know the plan far better than me. The government's just published it for getting to net zero. There's obviously going to be a residual amount of carbon, but there is at least a plan for that. There's much less of a plan for scope 1. So indebted to Jan Rosenau for this, that we always use now, in terms of, we're looking at the heating of our buildings. So most of the buildings that we've got use gas boilers to generate the heat. And unfortunately, it's very distributed. So unlike electricity, where you've got a few areas that generate the electricity, and then we all use it effectively like networks, most of our buildings, we've got a few networks, but mostly it's everything happening on site. The technology we're talking about, apologies for that, didn't do that on my thing anyway. The technology we're talking about is heat pumps. So it's the electrification. We're not talking about hydrogen or any of the other technologies that may or may not come about. It doesn't mean that over the period of time between now and 2035 and then beyond, we might welcome other technologies. But at the moment, what we're talking about is electrification. And this is again from Yan, 200 million heat pumps and that are installed globally. Not that many in our country. We're not very advanced in that yet. I'm really racing through this early stuff, and then I'll slow down a little bit. And I know that the idea is to move through fairly rapidly. If it's too quick or too slow, please just give us a shout. So we know that, so in terms of district heating, which is going to be the more efficient way of heating our buildings, and I'll come back to that, providing a low carbon heat, then we know that roughly 2% in the UK is provided through networks. And the government policy is to make that 20%, so it's to that fall by 10 times. The government has had this policy since around about 2021, 22, but it's not really been doing very much. Recently, it's accelerated all of that. There's now quite a lot of money behind it. The policies are really starting to come through. The Heat Network Development Unit, HUNDU, which is part of DESNZ, they are really pushing now for this. And there are organisations that are getting money to put in heat networks in parts of the country right now. Just on that, there we go. In terms of local policy context, I think the way that we are anticipating that this will work is that the government will fund 4 to 1 is what they're looking for. So they put in 1, they're looking for 4 times that. Individual companies will come and build the network and then and they will build it by bringing on a certain number of off-takers that will make the thing viable, economically viable. And the way that the local network will be enforced, if you like, for that word, and it's really quite contentious, this is through planning policy. So this is 2040 planning policy, which has not yet been adopted by the City Council. But the idea is that when we ask for planning consent for major development, then the way it will go is this. First, you can't have fossil fuel. Second, if you want to put your own air source heat pumps or whatever system you want in there, that's fine. You'll need a planning consent. If you don't want to do any of those things, you will link up to the local heat network if one exists. So there will be a form of requirement, mandatory. So some organisations, some local authorities, City Council, starting to look at this. For Oxford, definitely Leeds, Bristol, and some of the other ones, they're saying, yeah, that's what we want. We'll start developing a heat network using a private sector partner, which will be required for organisations to link up to it as they start turning over their estate. In terms of national policy context, this is there's a market overview document. The government's really pushing for it. So this came out in December. It's really just pushing to say to the private sector, come on, get yourselves together, apply for money. We'll put money in for you. You get it from private sector funding. There's a great market out there. If it is, there's barely anything there. It's all for the taking. So get on with it. So that's really some context in terms of strategy and UK strategy. It's not to say that we're going to therefore go for a network or a city network, but we know that that's going to be the most efficient way of doing it. And we'll come back to that. So piling ahead, what have we done? We've set up an internal program setup. So this is a classic kind of setup. We've got the steering group at the top there. The chair, we are still not 100% sure who's going to chair it, but it'll be somebody senior within the organisation. And there's a number of working groups. We split it into 3 working groups. One is focusing on commercial stuff. So this is going to be assuming that we are going to end up doing some negotiation with private sector partners. We've got another group called the Technology Working Group. This includes some of our academic colleagues, David Wallerman and Jesus Lasana, who will we will try and navigate our way through the sort of technology that's available to us. And then we've got our academic liaison group as well. So this is chaired by Paul Shearing, and we have a formal working arrangement with the Zero Institute. We are funding, part of this program is funding a postdoc research associate who will be pulling together a formal piece of work where we're going to look across. The aim of this work is to extract all of the value we possibly can from this program in academic research terms, and also for raising money. We've also got this at the top here. So this is being developed. This top left. This is the strategic collaboration off-taker steering board. So this is effectively the City Council. So what the City Council are very keen on us all getting together. So this will be the city, the county, us as a university, and Oxford Brookes University to look at potential for how we can have a city-wide decarbonisation of heat process. Now this is completely agnostic as to what the technologies might be, what it might end up being, but this is about collaboration. So we will be collaborating with them in some form. And this is all being done now. So we've had early meetings, we're setting everything up, so it's all happening. So in terms of the actual program itself, so what have we done? We've, and really many apologies for people who've already seen this, we've mapped the, this is both gas and electricity usage and therefore carbon emissions by cluster. And we'll come back, we'll take the electricity out and just look at the gas. But that's what, so we've done it by cluster on account of we're following what the technology is likely to be. We don't think the technology will be individual air source heat pumps or electrification per building. It's too expensive. The SAI Business School was a great test bed for us to do that. We did that with the one building. It was really expensive, much more expensive than trying to do it in clusters. So how we feel it will be is probably one or more networks covering our estate, and some buildings having individual solutions. The actual amount of tonnage we've got to reduce is here. So we in the strategy, in the background to the strategy, we used a baseline of roughly 20,000. To take off 80% takes us down to 4,000. So in our graph, our totalometer starts here, 10 years, we go from 20 down to 4. So it's quite a big job that we've got in 10 years. If we then take out, my apologies, so if we take out then the electricity and go for the gas, then unsurprisingly, the two biggest areas that use most of the gas is the Old Road campus, that's 25%, and the science area, which takes us up to about 65%. So these would be the areas to really, for us to focus on. And indeed, what we are doing is focusing on Old Road campus to begin with. It's only 13 buildings, but it accounts for 25% of everything that we do. So we want to use the Old Road campus to learn about what we need to do. The only problem with that is that it takes time to learn, and we may not have that amount of time, because it does feel like there are players out there offering heat networks, there's money available. It feels like now is the time to get on. Whereas actually what we'd really love to do is spend the next 2 or 3 years learning what we're doing at Old Road campus. But actually I feel that we'll probably have to accelerate Old Road campus and in parallel be looking at the science area and the city as well. So in terms of technologies, right now, I don't want to go on about this too much because the technologies are so well known to everyone around in the room. But I think it's worth just mentioning that from a market perspective, the technology that is on offer is the 4th generation one. So it's the high temperature network. And having talked to the market, we've talked to lots of people in the market, and the feedback we're getting is that a high temperature heat network is something which is likely to be more attractive to people who don't want to spend very much money on their buildings. So businesses, for example, they want to spend money on creating growth, not on their buildings. So if you pipe them hot water, they barely need to do anything to their buildings. Therefore, it's more popular. But as we all know, the 4th generation networks are not very efficient compared to 5th generation ones, and they have all sorts of other issues, which I'm not going to go into in too much detail. The 5th generation network on the right hand side, there was one that is, there are a few, but they're called a network. They serve maybe 2 buildings. There's one at London South Bank that's being looked at the moment that colleagues went to have a look at last Friday. It works on a much lower temperature It's much more efficient, but every building has got to either have its own boost of some kind, or each building needs to have some fabric work done to it so that it can handle a lower temperature. So as we start developing our estate, we'll be developing new buildings that can run on low temperature. The Humanities building, the Shortman building, is going to be the biggest, I'm going to say in the world, I think it's the biggest in the world, certificated passive house building. It's stunning achievement by them. Nothing to do with me, sadly, but that will be able to handle a low temperature. But the buildings next to it will not. So if we give them a low temperature through an ambient loop or a 5th generation network, we will have to put another or more heat pumps serving the building to boost that temperature. So pros and cons, and it's a bit like Windows and Macs in that when you talk to different people who like the 4G are really enthusiastic about it, people who like 5G are really enthusiastic about that. It's quite surprising to me. I would have thought, who cares, as long as you get what you want. So what are we doing? We are understanding our buildings. We're starting at Old Road Campus. We're looking at how much coverage we've got in terms of data and meters, and therefore how many more meters we need to fit. We're not metering our heat terribly well, so we're having to use a lot of gas meters rather than true heat meters. We are reviewing our existing controls. So we have to achieve a certain delta T. I'm keeping an eye on the time, so I'm not going to go into what that means, but it just means having an efficient distribution network within the building. What we're finding is that we're having to go to every single building and inspect it all. And so some of our larger buildings may take 5 to 10 days of inspection by an engineer to figure out what's going on with it. And that's because we don't have the information in the ground, to just tip up and have a look. So we've got to go around, have a look at how the building is. And in order that we can optimize the building to be able to handle any heat network of any kind that's a low carbon one. So we're doing that now in the understanding. We're allocating what we think we're going to use in terms of technologies across the entire estate to model what we think the whole estate will look like. And then we will then look at options for our outline business case, it's the OBC. So these are feasibility studies that we'll need to carry out in different parts to see what is available to us, how effective they are, how much it's going to cost, and how disruptive it will be. And that will help us to understand really what we're out to try and get. And we think it's going to be a network, several networks. We're going to have to pay for a lot of the optimization work of the buildings. It seems most unlikely that's going to leave us with enough money then to put the actual solutions in. We'll get the buildings ready. We're going to have to look at the market, I think, for that. So that's why I'm not going to preempt anything we're doing, but that's where we are. So I've said we're going to start at Old Road Campus. So here's some of the questions that we don't have the answers to, but we need to answer. So number one, how do we know when we've got enough data to be able to design the solution that we want? So we're working with colleagues. There's never enough data. We would like to fit meters in every single room, some kind of, whether if we could do that would be the best way of doing it, and have a full heating season. Better off 2 or 3 heating seasons of data. So we really need to understand how much data is enough, so that the perfect is not the enemy of the good, but on the other hand, we're not designing something that's not going to work or is inefficient. Simple one would be if we know that we've got certain peaks of demand for heat, but they only happen 2 or 3 days a year, then you wouldn't design a system that can handle those peaks. You design the system to handle the base load, you put something else in to deal with the peaks. But how do you know the peaks if you haven't got individual meters in every room or in a more delineated state that's covered that period of time? You can't do it. So how much data is enough? Second question, how do we approach resilience and cooling? So a high temperature heat network does not allow us to then run cooling from it as well. A 5th generation low temperature does allow us to run cooling. We know the building is going to start overheating, particularly the older ones. How do we approach cooling? Do we look at passive measures? Do we say, well, that's an electrical problem, that's a chiller problem, so let's not worry about it? We could do that. We've got to navigate our way, because that will determine then what the solutions will be for the buildings. And how do we approach resilience? if someone else is maintaining this system rather than us, is that acceptable for our more technical buildings? Buildings that absolutely cannot be without heat. So hospitals, it's a complete non-starter. They're happy to have a low carbon heat network of some kind. They will keep all their gas infrastructure. That's what they're saying to me, because they just can't. They can't have no heat. They can't have cold water. How do we? Next one. We know that one size doesn't fit all in terms of technology, so how do we assess the different technologies? Within our business case, we have to have criteria within which we look at different solutions and then assess them based on the right criteria for us. And we know that there's going to be compromises, so we need to sort that out. It's a shame I haven't got the answers to all this, I'm sorry. And then finally, I mean, there are more questions than this. How do we monitor to make sure the buildings don't slip back? So once we spend a fortune and a lot of time and effort optimizing the buildings, how do we then make sure, monitor them, and then make sure they don't slip back? Because that's what will happen. The buildings will start becoming inefficient. We might achieve by putting in different pumps, changing the controls, putting in valves and stuff. We might be able to get the delta T right for 5 minutes, and then will it just go out of whack again in a few months' time? By the time we bring in the actual the solution itself, that the building could be de-optimized again. Right, I'm looking at the time. Academic work streams. I'm not going to go into this in too much detail because I've mentioned it earlier, but the big question here is how do we make sure we maximize our IP and monetize and grant raise what we're doing here? So we need to make sure that everything that we do is we're not just giving it away to consultancies, and we're using it in the most imaginative way that we can to understand what we're trying to achieve. So all these questions, and we're working with the Zero Institute, like I say, to achieve, to try to approach that. So if we then look at the commercial work stream, so this is where we're now assuming that to a certain extent, whatever it might be, a large extent or a smaller extent, we're going to go to the market for this. And that means that we're going to be dealing with third parties to negotiate some kind of deal with them. So energy costs, there's no market really for this yet. So there are, people will say there's lots of networks, but actually there are loads of networks. We've got a network in the science area right here, but it's not a market provided network. So there's very few markets. So we can't go out to the market and say, well, what's the market price for electricity like we can now, or for data or whatever. It can't be done. So we've got to do our own deal. And in terms of commercial, there's not very many deals, and a number of the deals are secured through NDAs. So we can't get to them. So we're going to do a visit down to Bristol. We can talk to Vattenfall, I think it's called. So that'll be very interesting. There's an NDA in terms of the actual deal they've done. So we're not going to get into how long it is, what the deal is, how much they're paying for it, etc. So again, until the government start to put out a lot of terms and conditions and standard things, we're effectively negotiating a new deal. So firstly, how do we avoid enabling a potential monopoly? So we're looking at this for the long term. We've been here for thousands of years, 1,000 years or so. We want to be here for another 1,000 years. I don't want to be the person who helps to usher in a monopoly of heat. Want to get into our pipes? That's through us actually. If you want to maintain this stuff after your contracts run out, that'll be through us. You want the heat, it comes through us, and all of the infrastructure. At the moment, obviously, there's not that vertical integration. It's separated. Well, this is not happening here. This is all going to be vertically integrated according to the government policy, if you follow that through. Second, what are the key benefits and outcomes we need from it? So again, it comes really back to the commercial. So we have different requirements. If you're a public organisation, a city council, for example, then you might be looking for the widest appeal, the lowest costs to the widest number of people. It's lower costs. For what we might be after is something completely different. High levels of resilience, flexibility, cooling, control. So we need to balance these different requirements and understand what they might be. And then finally, this is the big one. how do we ensure that we get the benefits of being a first adopter and that those outweigh waiting? So the government policy, as well as encouraging heat networks to spring up here and there, they've also got a number of cities which are being used in what they call an advanced zoning program. So Leeds, Bristol, parts of London, a few others. And the idea is that they will do the whole lot, learn from it, and then from that will come a lot of learning. Now, I don't quite understand really why the government haven't just done that and waited. But clearly they're looking at the targets and saying, well, actually, we can't manage it. We can't wait for the zoning program to come about and then for us to learn from it. We will certainly miss our targets. We've only got 10 years. So how do we make sure that the first adopter outweighs? So the theory is that as a first adopter, we approach a supplier that's already got 10 or 20% of the cost of that installation funded by the government. Therefore, we can do a deal with them which is better than if we waited until we have players coming into the market that have got no government funding. So it makes sense, but I would refer back to everything else. NDAs, no deals in the market. There's a bit of a wild west. So we're sort of on our own, but there's potential to do better than we will do if we wait. That's a tough argument. So we have to navigate our way through all of that, hence that last question. And then really my final slide is just to tell you specifically what we're doing. So we're doing our soft market testing, so that means we're talking to lots of suppliers. We're on a constant loop of doing that now. What we're finding is all the things I've just said. So there are no experts in the field. We're all learning as we go. What we have done is we've got a load of free wins in that we've looked at the estate and what we think it's going to look like by 2035. We've been able to take quite a lot of things out that are going to be demolished. So I'll be able to report how many thousands of tons we've saved by doing nothing at all. So that's perfect. If we can carry on doing that, that would be brilliant. We're going to pull together our program of specific interventions. We're starting at Old Road Campus, and that will be a large program of works. We've talked about the heating and cooling consumption data. We will then go out to, we're going to provide at least one market-ready solution up to probably a REBA 1, maybe REBA 2 stages, that's design stages, sorry, that will then look at the market, we'll let the market look at it. What do you think of this? Do you think it works? Tell us what you think of it. Would you provide it? How much would it cost us? There's so many deals. In Bradford, for example, the deal is there that not only is the company, the private sector company, putting all the pipe work in up to the building, they're also doing all the work in the building. They capitalise the whole lot. You then pay for your connection, and then you pay for that over time. If you don't have the internal expertise or the capital, that's a good deal. So we need to look at there's every deal you can imagine really at the moment, it seems. What we're also doing is continuing to work with our colleagues at the city and the county, and like I say, at Brooks, looking at heat networks generally, technology agnostic, nothing specific, but really just the idea of a heat network. And that's it. That's where we're at. So that's what the university is doing regarding HeatNet, and I'm more than happy to carry on. Come back in a few months' time, let you know. But thank you for your time.